In the last section, we talked about side, 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 side angle, side, and hypotenuse leg congruence. Now, there are a few others that we need to talk about, especially these dealing with the angles. So, the first one is angle, side, angle, which we abbreviate as ASA. Now, this is what happens when you have two triangles that have two angles with the side between them congruent to each other. Therefore, the triangles must also be congruent. So I don't know if I could do a quick little sketch of one here, but let's say that we had two triangles and this angle was congruent to this angle, and this angle, let's say, is congruent to this angle, and the side in between them is also congruent. That's angle, side, angle, and that's a congruence pattern. Now we also have another one that is angle side congruence, and in this case, angle side, you have um, two angles and a side that's not between them, that's beside them. So if two angles and a side opposite one of these two angles of a triangle are congruent to the two corresponding angles and the corresponding side in another triangle, then the two triangles are congruent. That's a lot of mumbo jumbo to basically say if you have two triangles, let me draw them a little bit bigger this time, maybe that'll help. And let's say that we have this angle congruent to this angle congruent to this angle, and this side congruent to this side. That is angle, angle, side, angle, angle, side. So that's really all they're talking about. Okay, so just to kind of recap our congruence theorems, we have our side, 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 angle, side, hypotenuse leg, angle, side, angle, and angle, angle, side. Basically, there are only two patterns that don't work. The first one that we talked about in the last section is angle, angle, angle. You can't say that two triangles are congruent by angle, angle, angle. They'll be similar, which we'll talk about in another section, but they won't be congruent to each other. They won't be identical. The other is angle, side, side. If your pattern spells out the word ASS, then it is not a congruence pattern. So I want you guys to keep that in mind. There is no such thing as three angles. There also is no such thing as angle side side. Those are not congruence patterns. But basically, the other patterns work. Let's look at some examples and see how in the world this works together. Okay, here we have an example that says determine whether the conditions angle P is congruent to angle M, Q is congruent to N, and R is congruent to O are sufficient to prove that triangle PQR and triangle MNO are congruent, and justify your answer. Okay, so before I do anything else, let me draw out a triangle PQR, and it said that it was congruent to triangle MNO. Now notice that whenever I labeled those, since I started with P and went clockwise, then I had to start with M and go clockwise so that all of those parts would match up. Remember our talking about naming triangles and being very careful that our parts match. Now it says that angle P is congruent to angle M, so P is congruent to M. Q is congruent to N, so Q is congruent to N, and R is congruent to O. So R is congruent to O. Now, is that enough to prove that those two triangles are congruent? Think back to our patterns. What do we have here? We have angle, 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 angle. That is not one of our approved patterns. So no, that is not sufficient to prove those two triangles. Pardon me. And because this is not one of our proper patterns. Excuse me. Let's try another example here. This one says determine whether the conditions PR is congruent to MO, QR is congruent to NO, and angle P is congruent to angle M are sufficient to prove that these two triangles are congruent, and justify your answer. Well, again, before we do that, let's go ahead and let's draw out those triangles. So we have P, Q, R, and the next triangle here would be M, N, O. Now they said side PR is congruent to side MO, QR is congruent to NO, and angle P is congruent to angle M. So we know that much. Does that mean that we can say those two triangles are congruent to each other? Well, let's think about the pattern we have. We have side, side, angle. Or if we said that backwards, that would be angle, side, side. That again is not one of our patterns that we have to work with. So no, we do not have enough information to prove that those triangles are in fact congruent, because we don't have an approved congruence pattern there. So be very careful for those two. You want to watch out for them. Alright, and last example here, it says determine whether the triangles are congruent. If so, name the postulate or theorem that justifies your answer. If not, explain. Okay, so here we have two triangles that actually are put together to form a parallelogram. And if you'll notice, we have a right angle that's congruent to a right angle. And we have this angle here is congruent to this angle here. Now, if we could only show that we knew something else, then we might be able to use a congruence pattern. So let's see, what do we know? Well, don't we know that this diagonal here, isn't that the exact same for both triangles? So that has to be congruent to each other. So what do we have? We have angle, angle, side. Angle, angle, side. That's a congruence pattern. So we can say, yes, those triangles are congruent by the angle, angle, side theorem. Now, we're not going to focus a whole lot on quadrilaterals, but I did want to put some information in here for you to be able to look at and see how some of these are some of the properties of them, some of the names of them. You know, you have your trapezoids that are four-sided figures where you have two sides parallel to each other. And it says consecutive angles between parallel sides are supplementary. So that's kind of interesting there also. We have our isosceles triangle, in which our base angles are the exact same thing. Then we also have some cool figures, just your regular parallelogram. And remember what a parallelogram is. It's where the opposite sides of the parallelogram are parallel to each other. And here are some cool attributes that go along with that. So you might want to just kind of brush up on that, study up on those, and see what kinds of cool things that go along with those. So especially like your kites, you have a convex kite and a concave kite. Just different vocabulary and some interesting attributes.